All right, so starting in order, we're going to go through terrain and topography first, which is large-scale, like surface and shape of the planet kinds of characteristics. And we use that to tie in some of the latter things we talk about, mostly with air and water resources later or higher up in the stack. So again, that's terrain and topography. Bedrock, which is the same for you soil scientists as parent material. And then soil, vegetation and water, wildlife, human layer, so recreation sites, transportation, health, sanitation infrastructure like bathrooms, water treatment plants. A lot of these parks have their own infrastructure facilities. Cultural resources on that human layer as well, like those archaeological sites, like on-site festivals and demonstrations, cultural interchanges. If you go to the Grand Canyon, for example, you can go watch, any of a dozen different plains and southwestern Native Americans, First Nations groups doing things like demonstrating some of their like war dances or rain dances or cultural ceremonies like choosing or ratifying a new leader, or less commonly things like wedding ceremonies, or how they use traditional tools to field dress a carcass to use it all up, and so forth. And then above that kind of human layer, we have the air and near space layer, which is going to be things like physical air quality, nighttime sky, so haze, air shed, particulate quality, the soundscape, all of that stuff. Okay, so that's quite a stack of resources to go through. We kind of start on this in 220, so if you're taking that class, hopefully a little bit of this will be review, but let's get right into it. Hey, go ahead and get with your team, and we're going to take some notes. Everybody looks the same with masks, right? Yeah, there you go. Cool. So, starting with terrain and topography. Again, at our example park, not the same as what most of you chose. The chosen places we have this year are Lewis and Clark National Historic Trail. Very sweet. Not too far from here. Great Smoky Mountains National Park, the land of panhandling and overcrowded bears and the biggest salamanders you've ever seen in your life. Olympic National Park, a pretty place. Zion National Park, one of my favorites. C&O Canal National Historic Park. This is what hipster park rangers would call a deep cut. So, who are my C&O Canal folks? All right, cool. Later on in the semester, we're going to talk about people having sex there during research projects, and it's super awkward. All right. Next, U.S. Virgin, so stay tuned. It only gets better. U.S. Virgin Islands National Park. That is you guys, right? Cool. All right. So, this is quite a good range. We've got land and water focused parks, and that's good. It's going to keep it interesting for us this semester. But today we're going to use our sort of proxy or example park, Mammoth Cave, so we can start to get to know it for our November field trip and to just kind of practice or surrogate some of the steps that you want to take and chase down and kind of divide and conquer with your group in terms of getting to know your chosen park. So first, terrain and topography. This is karst topography. It is calcareous. You don't need to write that down because this isn't your park. What that means is it's calcium and magnesium rich minerals like limestone. And there are, in several smaller layers, things like shale, which is completely different. It's a lot less water soluble. It's a lot less etchable or dissolvable by slightly acidic water than karst is, limestoney type material. And so we get a bunch of water-created caves here. At volcanic parks, we have like lava flow tubes where the inside is still molten, but you get that sort of delicious crackly crust on the outside. Don't actually eat it, but you get a very different style of cave there. Here at Mammoth Cave, for the few of you who have been there, you know that it's like walking in a stream bed that just kept kind of sculpting its way down. And you have the sensation of walking basically in a 3D riverbed, because that's literally exactly what it is. The terrain here does not have big mountain ranges. Olympic National Park is going to have a very, very, very different profile just because of the fact that it is all about enshrining one or a couple of beautiful, beautiful peaks. And this is completely the opposite. This is sinkholes. So if you're not where you can see the squiggly little topo lines on the map, I want you to get up out of your seat, come on a little bit closer. This is worth taking a look at. So come on closer if you can't really see what's going on. We're going to look at the bottom edge, nearest edge to you of this map. So this is a unique place in terms of its topography because that basement bedrock, that extremely dissolvable material, is basically Swiss cheesed or spongified this stuff. This is the mad cow disease of landscapes. So looking at the very bottom edge here, do you see all the tiny little circles in these brown topo lines? Usually we're used to seeing a small circle on the topo lines and thinking, that must be a peak. Here it's the opposite. This is erosional or subtractive out of the landscape. Each one of these is a sinkhole. And what's the scale bar here? This is a mile, about 2.5 inches. Right here, this transect of 1 mile crosses like 8 different sinkholes. That's a ton of sinkholes. And that means if you're walking in a straight line around Mammoth Cave or through Mammoth Cave National Park, it's about a 6 mile by 6 mile area. You're not walking forward, you're walking up out of a steep sinkhole collapse zone. It's a cave gallery, a room that has collapsed and left kind of a pit or crater-like shape, an inverted cone, sort of collapsed down from the surface of the earth. So if you take a real close look at these topo lines, there are little hatch marks on the inner edge pointing to the downslope side. If you see topo lines like that on your park's map, take note. These are too small to show up in 3D models and imagery like on Google Earth or something like that. But where you see stuff like this, you really want to take note of it because for one of our later on layers for resources, it's going to make a big deal. This is gaining and losing stream territory. We're going to have any forestry hydro folks? Huh? Really? Wow. Okay. So even better. Nobody has a clue what's going on. So the idea with a gaining or losing stream is we think of watercourses like the Green River flowing through Mammoth Cave. We think of them as like discrete water bodies. Like there's a channel and the river goes through. With a gaining stream, without additional surface streams joining it, that stream volume, that river volume gets bigger. There's additional water flowing up underneath through the bottom called the hypereic zone in areas like this where it's just water's flowing all different directions through these different cave galleries and stuff. It's recharging or charging up the river and it gets bigger and bigger like all of a sudden. So you might be on a stream-sized section in your little creek boat kayak and then like you go around a bend and all of a sudden it's a full-size river and nothing's joined into it. It's actually flowing up. Nothing visible has joined into it. That's called a gaining stream. A losing stream or a sinking stream is the opposite, where, and if you've ever done any canoeing at like Jack's Fork River late in the summer, you know what this is like. You're canoeing along and the river keeps flowing. It just goes underground to do it. For those of you who were on summer camp this past summer on rec camp, we had a losing stream at Great Sand Dunes National Park and Preserve at Medano Creek. So the stream was going along, and then it just flowed under the sand. So you're walking along the creek, and then it's like flowing, and it just goes away. Okay? That's the kind of regime going on here. So for you at your park or other protected area, come on in. We want to know, what's the topography like? How is topography as a basic underlying kind of inescapable character of the landscape? What's that going to do to kind of force the behavior of all of the other layers stacked on top of it, including humans and our behaviors, okay? So here we've got a rough, variegated landscape. In other places, not so much. Olympic, it's going to be a fairly rough landscape as well. It's a big rock. Zion National Park, it's going to be a complex landscape, but Zion is in sandstone. Unfortunately, we didn't get to see it this summer. But if you do like a Google Maps or Google Earth kind of fly-through, you can have a creek that is 10 meters wide and 300 or 400 meters like cliff wall channelization, okay? So the topography at Zion National Park for that particular section of the Virgin River is called the Narrows. And highly channelized topography, where the river, when it's flooding, can't go sideways like in the Mississippi Channel and spread easily sideways. It spreads straight up. And so every once in a while, especially before they got kind of an early warning system and a permitting system in for places like the Narrows, backpackers would be in there and they would just get crapped out by a 20, 30, 40-foot rushing wall of water, and there's nowhere to go. There's nowhere to escape that. You can't climb 40 feet, in the 10 seconds where you're aware of this happening. So pay attention to the topography and how it might be forcing water flows in your particular chosen park or protected area. Other things to look at the topography level. So this is, when we're talking topography, again, we're kind of zoomed out on the map, a little bit further away. What's the bigger level going on? Other aspects of topography include things like, is there a particular directionality to major features? So, a lot of the world's biggest rivers in the northern hemisphere flow what direction? Anybody know?
Northwest to southeast.
Yeah, mostly north-ish to south, yeah. There's a reason for that as the Earth spins. Think about that. But is there a directionality to the features at your park? Or is it absolutely crazy, insane like this? So this topo map looks like a map of the surface of the moon. Except instead of impact craters, it is erosional subtractive features, sinkholes. But do you have a mountain range running through your park or protected area? What a mountain range is going to do is, if it's running sort of from me to you, and the prevailing weather pattern is perpendicular to that, that wind and everything that wind is carrying is going to hit that feature like a big speed bump. And air, our atmosphere, and water, they all are subject to fluid dynamics, how water and other fluids just flow. The faster that water or air is going, the more stuff it can carry. So in a tornado situation, we have forks getting driven into telephone poles and cows getting yeeted into eternity and so forth. I apologize if I'm misusing the hip argot of today's youth. Let me know. But as with big weather patterns, sort of bigger than tornadoes, hit a mountain range, they get forced up. And that air gets forced to cool off rapidly with adiabatic cooling. And that dumps all the rain on the windward side. And then the wind comes down the backside of the slope and it warms up. And it regains its ability to hold stuff like moisture. So you get on the backside of that slope, the lee or the sheltered or protected side of that slope, opposite direction from the prevailing wind direction, so over here, we have extremely dry areas to the point that it can completely select for a different forest or other kind of ecosystem, grassland, woodland, whatever, on one side of a slope versus the other. On summer camp, we got to see this, driving across the Rockies a couple different times. Okay? So, terrain and topography. Any questions about stuff like this? Let's take just a moment and kind of speculate with your group. Maybe you had a chance to look up your chosen national park or protected area. Maybe not. That's fine so far. But speculate for a minute on what the terrain and topography is going to be like for your park. This is a trick question for some of you because the Lewis and Clark Trail crosses a bunch of different kinds of topography. So, you guys chose a really interesting and difficult thing to manage. Like, Olympic, it's kind of one unit. But Lewis and Clark crosses how many states? What, a dozen states? Something like that? Okay. The big historic trails, like Lewis and Clark, the big recreation trails, the big scenic trails, cross a dozen or more states, cross hundreds of different kinds of ecosystems, and thousands of adjacent landowners. So, it's complex. I'll have to say, if you guys want to, choose another place, that's fine. I'm cool with that. Let's pick something else early, If you want to go hard on Lewis and Clark Trail, great. That's great. But think for a minute, what's the topography like east side versus west side of the Smokies? There's a meaningful difference between those inside the perimeter of that park. Okay? Cool. So, get with the group, just chat for a sec, and we'll come back together and discuss. What's up?
I want to change ours real quick.
Okay.
Smokies to Isle Royale.
From where to where?
Isle Royale. From the Smokies to the Royale.
Oh, Isle Royal. It's a beautiful place. Now, it's spelled Royale, like Royale with cheese from Pulp Fiction, but it's pronounced Royal. So, yeah. Canoeing among the wolves and moose. I like it.
I thought they got all the wolves off there.
Did they? Finally? Okay. Yeah, that's going to be a change, for sure. Feel free to use your phone or other device if you want to kind of reconnoiter. And don't zoom in too far. Again, terrain and topography, this is a large-scale thing. This is the stuff that we're going to start observing from, 150 miles up in space kind of thing. All right? There will be plenty of time later in the semester to drill down into site-specific, so individual points of interest within your particular park or protected area or along the trail, for example. Okay? But those aren't going to be big enough to affect things like weather. They're largely going to be affected by climate patterns and long-term weather trends and so forth. The basic fluid dynamics of air and water washing over it. Another aspect of topography at this kind of level, we're kind of getting to know your park for the first time, or the protected area, is going to be scale. So here we've got 2.5 inches or so, 2.5 inches on this Mammoth Cave map. It's a fairly small national park. It's east of the Mississippi. Most of those tend to be much, much smaller. Thaddeus Kosciuszko, the smallest unit in the national park system, is like 0.016 acres. Right? You're going to manage that pretty differently than Olympic. necessarily, because Olympic is not small. Okay? So, start to get just a basic sense of how big is this place? What kind of general ecoregion is it in? Am I talking desert southwest? Am I talking oak hickory, mixed bottomland hardwoods, mixed fire regime, fairly recent agrarian land use like on the Shawnee? Am I talking north end of Lake Superior, one of the coldest, largest, and deepest bodies of fresh water in the world? That's going to have a pretty different set of topographic considerations than Zion, which has very, very little water. Completely different wildlife, completely different climate. That's what's going to keep all this interesting. All right, so what's the scale of this place? Isle Royale is several miles wide by a couple of miles thick, and that's it. Zion National Park, because it is canyon country, has a couple of pretty distinct faces to it. All the stuff, all the development is down in the canyon, inside Zion Canyon. And all of the high country there is pretty remote. It's a lot like Yosemite, for those of you who've been there. Tons of stuff happening in the valley with lodges and restaurants and campgrounds and all that stuff. Same thing at Zion. And if you go up to the high country, you basically have it all to yourself. We go there in peak season when the buses actually last that long. And we go on some of the busiest weekends of the year, and we don't see another soul when we go up to the high country in one of the most popular parks in the world. So, another aspect of terrain and topography, following basic shape, directionality, like of mountain ranges and so forth, or what direction is the river flowing? Is it cutting off a corner of your park? Is it the entire park, like C&O Canal National Historic Park based on the Potomac River? Okay, that's going to be a couple of, 150 plus miles, real thin ribbon of a park. Okay, so after directionality and shape and size, what kind of heterogeneity do you have? Is it all sort of one show? Is it all kind of this kind of same face throughout? Or is it broken up into like visibly distinct units? Canyonland National Park is cut into thirds by the confluence of the Colorado and Green Rivers, I believe, in Utah. And the three districts are really pretty different from each other. One of them's super busy. It's got a town nearby. And the other one on the other side of the river from that is real quiet. So what's the topography of your park? Is it chopped up like a Canyonlands? Does it have kind of two distinct tiers or levels or stacks like Zion or the Grand Canyon or Yosemite, with a low kind of riverine level and a high up country or upland level? All right? Next thing to put on your list of topographic characteristics, and this is going to get super geography wonk, but don't worry, we'll take you right through it. What's the edge to interior ratio of your protected area of choice? A trail or a river-based protected area is going to have lots and lots of edge and not a lot of interior, okay? Sort of the edgelord of parks, if you will. C&O Canal National Historic Park is a couple of 100 meters thick for most of its 100-plus mile reach along the Potomac River. That's cool. That presents a completely different set of challenges and interesting opportunities for forest management, for rec management, for zoology, than a largely interior park like Olympic. It's got a relatively few number of miles around its perimeter relative to the size of the area that perimeter wraps around. Okay, so is it a long, skinny ribbon with lots of edge and very little interior space? Or is it a big sort of circular or squarish blob? Our example for today, straddling the eastern Green River, not the one in Utah, but Mammoth Cave National Park. it's not real long and stretched out. It's not emaciated or attenuated like a C&O Canal or a Lewis and Clark National Historic Trail. It's kind of the opposite. It's fairly blobby. So if you have to drive around the edge of your park versus driving through it one side or the other, if the drive is kind of short in both cases or approximately closer to similar, that's a low edge to interior ratio. It's a big chunk blob of a park. If it takes you forever to drive around the perimeter and you could jog across from one side to the other in a minute or less, or a couple of minutes, like a national trail or C&O Canal, that's a very high edge to interior ratio. And those two situations are really pretty different in terms of day-to-day management. Okay? So at C&O Canal National Historic Park, this is giving away the secret sauce a little bit too early. We're not going to talk about human factors until a little bit later in the semester. But one of the things they really got to worry about or manage carefully at C&O Canal National Historic Park is people fishing for dinner in the Potomac River. That is a nasty river. You're going to get STDs we don't even know exist yet by swimming in that water. And B, it's a highly channelized river. There are 80-foot bluffs in the section of the river on both sides that runs through Washington, D.C. So when it floods, just like the Narrows, it floods up before it can flood out. And it's got to flood up 80 feet before it can start flooding outwards. That eats houses, okay? It creates whitewater rapid features that you see somebody's mobile home floating into, and then it just disappears into the hydraulic feature, the specific whitewater rapid, and then nothing pops out. It's just gone, okay? So topography makes a difference in what it's like to manage and work at these places. That's pretty cool. Does anybody have any questions so far on topography? We don't usually spend a ton of time on topographic effects in forestry classes, so some of these terms might be a little bit new. I don't want to drop anybody back off the peloton just yet. Questions so far? Cool, I'm perfect at explaining everything, and you guys are laser focused. I love it. Cool. If there's anything that I'm not explaining well, stop me right then and we'll cover it so that everybody's good to go with it. Okay? Cool. So let's hear from you guys and gals. What kinds of topographic characteristics, what kind of landscape scale characteristics, what kind of ecoregion characteristics are you noting, or ecoregions in the case of C&O Canal and Lewis and Clark, excuse me. What are you finding so far?
Well, so we're doing Olympic National Park over here.
Okay.
Definitely some mountains.
Definitely some mountains. We've been known to, yeah.
Another ecosystem, rainforest.
Temperate rainforest.
Yeah.
It's a little bit different than what we're used to, yeah.
Which is pretty cool.
It is lush and green.
A lot of ridges. A lot of ranges as well.
Okay. So in terms of scale, pretty big. This would eat Shawnee National Forest for breakfast, wouldn't it?
Absolutely.
Yeah. Okay, so we want to keep that in mind. Some of the things that we're used to seeing here, kind of out east, not the right fit out there, just size-wise. And that's okay. It's not a huge surprise when you get out there, but we just want to be thinking in that way. All right, anybody else? Topographic characteristics, distinctives of your protected area. What about the edge to interior ratio? What about the directionality of it? Are you a long line transect north to south like the Appalachian Trail? Do you run sort of east by southeast to west by northwest like the Lewis and Clark Trail? And if you're kind of scrabbling to find this stuff initially, because we just started this, that's fine. You're not being quizzed today. No big deal. Use Google Maps. Use nps.gov/ the 4-letter code for your park, if it's a park service unit. If you chose C&O Canal, I believe the 4-letter abbreviation is CHOH. Chesapeake in Ohio.
That's tropical forest. 40-foot water.
So there's some elevation change there. That's not a flat little atoll. Awesome.
And there's a monument,
Good.
but that's like,
There are trails through it.
What do those trails look like? Are they like roads in Kansas, or are they like sharp squiggles?
This one has like sharp. Well, no, these are definitely roads, but like the whole island is what it is the national park.
Uh-huh.
So there's obviously, roads going through it, but there's, major waterways that almost split the whole island right there.
Okay.
Yeah, I mean, looks like there's only one like river that on this map, but I'm sure there's other ones.
Okay, right on. So you guys are going to have a lot of streams and other water courses radiating out, kind of in all directions, different sizes.
It's got 1,800-foot elevation.
1,800 foot on that tiny little island?
Yeah.
That's pretty steep. All right. All right, so if you are the island of St. John, your management's going to look pretty different than a long, skinny feature like a trail or riverine parks that you've selected. Okay? So edge to interior for U.S. Virgin Islands National Park going to be a lot lower than some of these other ones. Okay? Remember, it's the edge to interior ratio, so it's one length divided by the other area. Okay? So the specific numbers of C&O Canal National Historic Park being, I don't know, it's like 140, 150 miles of river or something like that?
I think it's 180.
180. Yeah, it's 40 miles between friends. That's going to have, if it's like bank on either side, and it's 180 miles of river, then it's going to be a little bit more than twice that length, 180 miles, so 360 miles of edge to wrap around that 180 miles on both sides of the river. Okay? That's a high edge to interior ratio, more than 2 to 1. Okay. The absolute opposite end of the spectrum would be for a park a little bit more like St. John's. That is a lower edge to interior ratio, closer to a circle. Okay? So, there we go. What else are you guys and gals finding about the topography, the geography, the landscape, the ecoregion? We've got a temperate rainforest out west. We've got a tropical island, maybe rain-ish forest in the Caribbean. Not the Caribbean, the Caribbean, named for the Carib Native American tribe. Okay? Take a look at the lineal or linear or line-like features. Roads and trails. Are they pretty flat and gridded out, like if you live in Chicago or Kansas? Or is it a spaghetti pile, tangle, hairball of a mess, a Gordian knot of trails bending back on themselves, crisscrossing water courses and so forth? At Olympic and at U.S. Virgin Islands, we're going to have a lot of things necessarily arranged by basically fundamentally being conically shaped. Okay, so you got a big peak in the middle, and everything sort of runs down in elevation in all directions from those prominences or high points. And so you're going to have streams, rivers, access trails trying to get from the low country to the high country up to the summit, for example, is a very popular recreation thing to do. So we as foresters need to plan on our human wildlife species making summit attempts, or summit assaults as they're called. Okay. Do you have your streams and trails kind of radiating around or all away from that high point, or running to that high point in the case of trails and occasionally roads? Do you have a road going through? Topography is a very strong influencer of that. Okay. Are those trails straight? Or is your topography and terrain, if you have a search and rescue situation, it might be hours or days before you can get exfiltration crew to somebody in distress with their femur poking out. Okay? We're going to have the whole range. With C&O Canal National Historic Park, there are neighborhoods on both sides of most of that 360 miles of perimeter. Okay? Some of the richest neighborhoods on the face of the planet, believe it or not. Which stinks, because doing research there, even getting like a Blimpie sub is like $15. Speaking from personal experience. Anyway.
No.
Anybody got some pretty mild, generally, trails or more or less straight-ish viewed from space? Or do you have genuinely burly, difficult-looking squiggles that cross a bunch of elevation? What kind of terrain and topography are you looking at? For Zion National Park, for the Virgin River, the sort of low country section of Zion National Park, do you have a bunch of trails running parallel to the track of the Virgin River? That's a very common conformation of trails, like you'll see at C&O Canal National Historic Park, like the Billy Goat Trail is a very famous, world-famous trail at C&O Canal. Or do you have a bunch of trails that radiate away from the river and go up these crazy, 1,000-foot plus, basically cliffs? And you'll see a lot of zigzags and switchbacks or climbing turns in the case of mountain biking trails, or horse trails, or equestrian trails. Same thing. What's the shape of the landscape doing for your infrastructure? For Isle Royal, what's the pattern of the ridge lines on this little island? It's what was like a 3 by 20 mile long island, something like that. So, not real big, but that's okay. Hey, come on in, just get with your group. You're fine. We're talking about terrain and topography of your park. So, the pattern of ridge lines at Isle Royal is very distinct. And when we get to the geology section, I want you guys to find why that island gets struck by lightning so much that it's called the Mount Olympus of North America. Native Americans actually thought that the gods lived on Isle Royal because lightning hits that island over and over. It's Ike and Tina Turner stuff. It's really bad. Okay, so just kind of file that away for our next section, geology. Right. And we certainly have not gotten to the point of evaluating your wildlife yet, but for your general basic sense of megafauna, that is, creatures that are approximately the size of within the human size range or larger. So moose, elk, whatever, different kinds of eagles can get pretty big. California condors at some of these southwestern parks, and so forth. Does the topography of your park lend itself well to the necessary migrations and habitat varieties that just a conceptual, a hypothetical wildlife species beholden or obligated to survive in your park because everything else around it maybe is developed or is ocean or what have you, can that animal migrate from one side to the other as a land animal or as a flying animal? Okay. If you have big mountain ranges bisecting your park, the east side may have almost a completely different biota than the west side. If that mountain range is running north-south, just kind of cutting it in half. Okay? Or do you not have those kinds of restrictions? And yeah, wildlife could pretty well get from one end to the other, even along the long edges, without too much trouble. Like along a trail or a river. Now, not all sections of the Sino Canal National Historic Park riverbank, the Potomac River, is going to be easily navigable. Those 80-foot bluffs or cliffs, those are a serious impediment to deer, for example, getting from one side to the other. But if they're traveling along the river, they're probably fine. Okay, so zoom in, zoom out. Think about this place in terms of its effects on people, talking about trails and roads and placement, stuff like that. Think about the effects of topography and landscape on hypothetical wildlife species. Again, we don't know the full list of species that are present and of key concern, rare, threatened, or endangered, for example, at your park yet. We'll get there. But for a hypothetical, like a California condor, can it just cruise from one, soar from one end to the other? Or is it definitely not making it over a series of ridges like the Front Range of the Rockies? Because that's not passable at that altitude. Okay? Cool. All right.
That's the only native mammal.
Well, I mean,
Native.
terrestrial.
Terrestrial. Well, obviously they fly too.
Okay. And finally, at a 40,000 foot level, so looking down on your park from the altitude of a cruising jet, what is the terrain doing in terms of human land use in general? Like, is your park recovering farmland? Like the Shawnee National Forest is? A bunch of cellar holes and ag species in the middle of the forest? The forest regrown and sometimes artificially replanted around it? Or is this so steep or so dry or so isolated by ocean or Lake Superior or something like that, that you don't see a lot of 40,000 foot level patchwork historic human use on the landscape, like farm quads and stuff like that? And again, we'll get into the human layer later, but for some of these, human use is a huge thing, like prior human use is a huge forcing or shaping factor relative to the topography. All right? So a park in a river delta is going to look and function and be managed very differently than that same river 100 miles upstream, because the channelized part of a river versus its delta, really fundamentally different landscapes, even though it's the same body of water. Okay? All right, so take a minute or two to kind of look at any evidence, again, just from a 40,000 foot level. We're not zooming in, we're not getting into the details yet. That's not a landscape level thing for human use. And then we'll take a quick break. You can pull your mask off or get some fresh air or whatever, as long as you're safely separated by 6 feet or whatever. Then we'll get back to it and do our thing. What time are we coming back? It is 2:50 right now. Let's resume at 3 p.m. And if the humidity and general warmth in this room has reached sort of an amniotic level for you, please, by all means, get some cold water. Move your body, get your blood circulating again. This is a tough place to have a class, so be kind to your body. Move. Get that lymphatic system circulating with some motion. Royale cheese.
I literally was like,
First thing is changed by the president. Only the list of
I don't blame you.
I'm glad there's at least two of us. I could not do this. Yes. That's what I was thinking.
I had some classes I had to squeeze my way in because they're full.
Dr. Park,
What's up?
here is this. I'm sorry about it being a while.
My brain. No. Cool. Thanks, man.
Yeah, I didn't really do anything with it. I just forgot about it.
Okay. Yeah, no problem. This will come in handy for a field trip for sure. So. I know, that looks like
So that actually came with like a huge backpack.
it's like sumac berries, but the stalk is all wrong. I don't know, was that on the Shawnee or?
Like that with me or
oh
something.
no, someone just sent it to a group chat and I it's for us. The group chat. I think it's either Jack in the Pulpit or green dragonberries.
I'm used to Jack in the Pulpit having pretty different berries than that, but I'm used to it from the Northeast U.S., so it might be a different variety.
What are you thinking about?
Just looking at the names of the places here on the map, and we're not at that part yet, but that's a fun conversation. Entirely separate from that, you see that Saluki Comic-Con is back on for 2022.
Comic-Con?
Yeah, they have a bunch of tabletop wargaming stuff too.
I didn't know.
Check it out,
They
yeah.
used to do it every year.
Yeah. It's, I think it's set for late January? Something like that. They rescheduled it from like the past 2 years. But. All right, one last thing for terrain and topography. And then we'll move on to geology and stuff like that. Or basement bedrock, parent material for your soil, whatever. So the last thing that we kind of want to get on this pass through for terrain and topography is looking at specifically the border or borders for you with multiple units, multiple disconnected units. Is it entirely a border that is defined politically, tends to have a lot of straight lines and angles, or is it a border that is partially political, partially geographic, meaning defined by, does a river form one border, or does a shoreline form a border, or does Canal National Historic Park have a bunch of straight lines around very wavy natural lines in the course of the river? They had to add some property on either side of that to capture the banks and so forth. So is it all sort of at one end of that spectrum? Is it all at the other? Is it somewhere in between? At Mammoth Cave, our proxy or example park for today, it's mostly political borders. What I mean by that is straight, sharp lines and angles. And the natural features, the peaks, the water courses, the shorelines, and so forth, they don't clearly influence what is park and what is not. And that has some real day-to-day implications for what your life is like when you're working as a ranger in one of these places, or as a wildlife professional, or any of the various disciplines that are going to be on site. So a place with a bunch of very political borders, like Yellowstone National Park, which is not one of our parks for direct study this round, but it's basically a big square on the map in northwestern Wyoming. Anybody ever been to Yellowstone? Okay, so the landscape there is not square, nor is it particularly flat. And so what we found when we set aside Yellowstone National Park as the first national park in 1872, before we had good ideas about maybe our boundaries should have something to have any reflection in reality on the ground, is that putting fences around Yellowstone and putting up a bunch of ranch land around it and barbed wire cut off the bison to the point that they were freezing and starving to death because they couldn't get down off the high elevation Yellowstone Plateau along what is now the John D. Rockefeller Memorial Parkway and down into what is now Grand Teton National Park. So we got Yellowstone, it's a big square up here. There's sort of neckbeard of Yellowstone, John D. Rockefeller Memorial Parkway. That's disrespectful. Rockefeller helped set up a bunch of national parks. Rude. And then Grand Teton down here, running north to south. And also high elevation down to lower elevation, at least in the Snake River headwaters, kind of down below the peaks of Grand Teton. And the bison needed that migration route to get down off of that super cold weather so that they didn't have to stamp through 6 or 8 foot high snow drifts all winter long and run out of calories to survive. We'll talk more about energetics and the metabolic budgets that key wildlife species have in parks a little bit later. But all that to say, when we draw lines around parks, the older a park is, the more it tends to have a political defining edge. The younger a park is, with the advent of things like landscape ecology, modern forestry practices, all that stuff, tends to have, hopefully, a more naturally informed or geographically informed boundary. So, zoom way out, turn off the satellite imagery on whichever map apps you're using, and look for sharp lines and angles, or very sinuous sort of natural watershed boundaries, water flow feature edges. What kind of an edge or boundary does your park or protected area have? Okay, you tell me. Those of you who chose islands, this is super easy mode.
Well, I mean, the boundary does extend past the shoreline. So.
It goes to the other island, but it's not British yet. It's U.S.
And apparently, just south of it, there's a separate national monument site called the Virgin Islands Coral Reef National Monument. That's all just ocean.
Where's that island? Where's Castle Island?
Castle Island.
Castle. It's got, it says we have Castle Island, but it's part of St.
I know there's an island. It looks like there's an island.
So for my Sino Canal National Historic Park folks, if you guys have a smartphone or tablet, kind of zoom in on the map a little bit. It will look like it's very natural, but you'll see a lot of straight lines for each individual section of the edge or boundary around that, and so forth. There's a lot of history with Sino Canal National Park, the National Historic Park. Parts of it were actually laid out and designed by, you may have heard of him, George Washington. Pretty cool stuff. So we'll have some old political boundaries there.
Okay, that's Castle Island.
Here it's like the wilderness. Keeps it in.
So do we, since the Coral Reef National Monument is separate, do we still want to do that? Do we want to do kind of both? What do we just want to stick with the terrestrial national park?
So one of the consequences of natural versus political boundary lines is going to be one of the sayings that we get out of Afghanistan, which has been in the news a lot lately, if you've been paying any attention. Better to be a pauper in the upper watershed than a king downstream. Because if you are managing the upper watershed for your park, and maybe the bottom of the watershed too if you're managing an island, you have good control over the inputs to that system, and that can make a world of difference. If you have to accept the land use practices of other folks upstream, for example, because you're a politically bounded park instead of a sort of geographic or naturally bounded one, then you still have all your tools available to you, but you have to sort of accept all of the conditions imposed on you by anybody upstream. Okay? For a long and linear park like Lewis and Clark National Historic Trail, you're going to be cutting across a bazillion watersheds and stuff like that. So it's a whole other game for you. All right? Cool. All right. Any questions on terrain and topography? Is everybody kind of getting the gist of just how we're kind of looking at the map and starting to reverse engineer what went into this park, how it ticks, how it runs, and why? Even just at a super gross, not detailed topography level? Any questions so far? All right, cool. So our next section is going to be something that we're not probably mostly deeply versed in. That's going to be like bedrock, parent material, and soils. Okay? So you're going to have to rely pretty heavily on your parks or other protected areas website, in particular, especially if it's a U.S. National Park unit, the management section on the website, and dig into some of the reports. So that's not something we have a bunch of time for right now, but let me take you through a couple of things to look for on the map and in any of the information materials about your park available online. The reason that we're sticking to federally managed places for this semester is that they have big budgets to put together this info because they need this info to make good decisions long term. Smaller like county and state parks, stuff like that, they don't always have the horsepower to do some of the stuff that we're doing in this class. So we've kind of smoothed the path a little bit, so to speak, by making sure that information is available to you across all these places. If it's federally collected information, unless it's top secret and restricted for military access, it's public information. It is not even copyrighted. It's literally in the public domain. So all that stuff will be available to us. This one's going to take a little bit of digging outside of class. But if you want to get where you can see the map here, either move your body or if you can just sort of peek over somebody's shoulder, I'll take you through some of the soil and bedrock material considerations for our example park here, Mammoth Cave. So we were talking just real briefly at the beginning of class about how Mammoth Cave is largely defined by limestone and shale. Limestone is basically a whole bunch of microscopically small calcium and magnesium-rich sea creature shells, all sort of sedimented together in the shallow ocean and then sort of gently pressed into limestone. What that means is because rain is slightly acidic, naturally about a pH of 5.6 because of carbon dioxide in the air, you may have heard that there's carbon dioxide in our air and that it has effects. One of those effects is that the carbon dioxide slightly carbonates the water, not to the point of forming bubbles, but to the point of forming carbonic acid. So when you drank way too much mellow yellow or code red as a kid and got a bunch of holes in your teeth, that could have been from bacteria feeding off of the sugar in those sugar chemical slurries that we call soft drinks, or it could have been the direct dissolving action of the carbonic acid from the carbonation in that soda. Same thing is true here. And what it does is, just like with your teeth, which is a calcium fluorite mineral called apatite, which is funny because it's your teeth. It's called apatite, but it's not spelled like that, appetite. I'm always hungry. Anyway, it's doing the same thing to this also calcium and magnesium-rich material, limestone, and it eats through it really rapidly. So if that hypothesis for that process is correct, then we should be able to see, as a function of the kinds of material in this landscape, things like sinkholes, but B, things like concentrated flowing features of this weak acid solution, carbonic acid in water, cutting rapidly through the landscape that it's in. All right, so the Mississippi River in our area is not really flowing over a bunch of limestone, for the most part. So we see it relatively flat. It's got a big floodplain that the actual river kind of meanders back and forth following different flood events, and it'll jump from one channel to the next or scrape out a new one each year with each flood event, and so forth. Okay? We have the opposite here. It's so susceptible to getting dissolved at a geologic weathering rate that if you look real closely, every bend in the river of the Green River here has lots and lots of topolines stacked on top of each other. These are cliffs. This river is chopping down so fast, it's not leaving itself a Mississippi flat basin to meander and form additional side channels in and that sort of thing. It's totally the opposite. And that's exactly what we do see here. Lots of, it looks like it's almost sort of shaded brown, but it's because there's only a couple of 100 feet of vertical change here. Like, these are not huge mountain peaks, but it is slicing straight down. It's scalpeling its way through instead of rasping or filing or shaving off the entire channel width surface like the Mississippi does. Does that make sense? Okay, so think about the watercourses in your park. Without even knowing what the specific minerals underlying, the rock formations underlying your watercourses here, the speed at which those channels are being cut is a pretty good clue to how geology is kind of forcing the rivers to flow, if that makes sense. Water is an irresistible force, and the bedrock here is the immovable object, except that we can start chewing away at it pretty hard. Now, one opposite version of this we can see in southern Illinois. So, limestone minerals dissolve super easy in water. They dissolve so fast that this Green River is called the Green River because it looks green, because it's chock full of calcium and magnesium ions in it. There's so much dissolved rock in that water, it's green. Okay? And we have the same kind of thing here in parts of southern Illinois. Some really, really beautiful, like bright blue or green, depending on the depth and the specific mineral local content in spots on the Shawnee. And you guys like to rock climb? Cool. We talking like sport climbing, like gym climbing? You want to get out on the hard sandstone of the bluffs? Jackson Falls, you may have heard of it? Yeah. Do you send problems? Full send? No, I'm not hip. I'm sorry. Anyway, that's like climber lingo for doing things. Anyway, so we have very much the opposite kind of geology in places like Yosemite Valley, which is strongly granite-based, and here in southern Illinois, where we have basically real hard, hard-pressed, hard, compacted, formed sandstone. Sandstone, in the opposite end of the range of dissolvability, is chiefly what minerals? Anybody know? What crystal? What makes sand?
Gypsum?
Gypsum is a salt and highly dissolvable in water.
Silica?
Silica, exactly. So silica is a silicon atom and a straight line between a pair of oxygen molecules. One double bonded on this side, one double bonded on that side. It's a non-polar molecule. Water is an oxygen and two hydrogens, but the hydrogens are bent. Water is a polar molecule. Water has a hard time dissolving sand, silica, quartz. This is why, when you go to the beach, the water tastes salty because it's dissolved all the salts, and you're standing on sand because it can't dissolve the sand. So gentlemen, if you really love her, and you want to go with like the old school traditional buy her a rock, put a ring on it, put quartz on it. because that's far more thermodynamically stable than diamond. And hundreds of millions of years from now, she'll still have that quartz crystal when the diamond's long gone. I'm serious. I'm just saying. I'm just saying. Yeah. I mean, I got my wife a diamond. Yeah. I caved to society's pressure. But anyway, hundreds of millions of years from now, I'm going to regret that. Anyway, what was the question? No. So, but think about this, all right? So the kind of parent material makes a difference. If your park is, or protected area is largely quartz-based formations like granite, you're going to have a lot of stuff that you could throw water across it for hundreds of thousands of years and not really see much meaningful change, unless it's a loose, so decomposable kind of granite where you get freeze-thaw action, which blasts the granite apart without dissolving it whatsoever. So you have sandy beaches. And so at Acadia National Park, on the east coast of the United States, an island in the Atlantic, it's a bunch of granite domes that are like hundreds of millions of years old, and they're still there, even though like the Atlantic Ocean has been hammering on it since forever. It's granite, and it's just sort of honey badgers long. Okay, the White Cliffs of Dover are made of talc, which is also extremely water insoluble. Which is why those extremely soft, with waves getting pounded against them constantly, that's why they're still there. Okay? So, to the extent that you can, for your park, figure out what's the basic dominant short list of 1, 2, 3 minerals that are forming the parent material underneath your soils, that your rivers and streams and so forth are flowing through. And as a class, we don't have to be geology majors. We can figure out together, is this a pretty highly soluble situation? Is it an abrasive, corrosive situation? Like, is your park volcanic? And if your park is largely soil made out of ash, then that means something really pretty different than if your park is mostly quartz sand. Pumice is extremely abrasive. I go through hiking boots at a rate of about a pair for every 10 days. I'm doing a research project in a volcanic rim. Okay? That's why we use lava hand soap to, pumice-based hand soap to abrade, crusties like automotive oils and compounds off of our hands as much as to wash it off, physically scraping it off. Okay? So, do some hunting between now and Monday on what's just the short list. We don't need a detailed Statsko or Sergo powered soil and rock substrate map. But generally, what kind of geology are you talking about? Because that's going to force a lot of stuff, just like topography does. Okay. Sometimes those two things are profoundly related. You may find in the Olympics some volcanic material. That'd be pretty cool. That's a pretty different deal than this karst stuff here. Completely different. All right. For Isle Royal, somebody may have chosen Isle Royal as their park this semester. In that parent material, we also want to know, is this place, in its historic land use, is another set of clues for the geology. Has this place been intensively scrutinized for mining? So the metal content in ores at Isle Royal National Park is so high that the entire island is basically, physically, literally, and I mean that not in the sense of Zoomer literally figuratively, I mean literally actually. It's the lightning rod, because there's so much copper in the ground there. Some of the world's largest copper mines are on the south shore of Lake Superior, and to get to Houghton to take the ferry up to Isle Royal, a 6-hour float ride, you got to drive by these absolutely stupefyingly huge open pit copper mines. Well, that formation extends up to Isle Royal, and local Native American tribes saw it getting hit by lightning so much because of that copper content that they thought the gods lived on that island. And so they kind of pieced out of there and left that island alone. And then we had white folks coming in and try to mine the heck out of it. And so there are a bunch of like open mine pits and shafts. Like there are places where it says, do not go off the trail in the middle of the wilderness. Do not go off trail here, you will die, like falling down a mine shaft, and that's the end of you, and we're not even going to bother with a spatula to get you out. So, in other places in Argentina, they have signs at the side of the trail saying, this is an active minefield area, don't go off the trail. Penguins that live down there are not quite heavy enough to set those mines off, but hikers are apparently. It is a self-solving problem. Nobody makes that mistake twice, but, enough different people coming. Anyway, so do you have, like, rich ore concentrations present? At Arches National Park, it is surrounded by the Chinle Formation, as we saw on summer camp this past year, and there's a ton of uranium mines all around, like, just tucked one ridge line away from where you can see them from the highway, so that people don't freak out, because, having big piles of yellow cake tailings on the side of the road is a real buzz killer. You do come home radioactive, though, with extra limbs and things. So get a sense of what the minerals are at your site. Again, just a short list. From there, we move up into the soil. So the decomposed rock becomes, eventually, fertile soil the closer you get to the surface. You're talking about a sandy soil, a loamy soil, silt, is it clay pan? Even inside of your park, you're going to see a little bit more variation here than on parent bedrock material, more here in the soils than in topography, characterizing like your entire park and its region. So this will be a slightly longer list, but I want to get a sense of if you are managing very like pure sandy soils, like at a coastline, for example, if people are walking across those dunes and snapping with their feet the root hairs and root runners for the shallow-rooted shore grasses, in a single day, a single family group of hikers can cause enough damage to completely erode a dune. So if this is the dune running like this, and we're walking across it, we go up the dune and go, oh, there's the ocean, let's go! And we all run down and we go play and have a good time. Our footsteps behind, for the most part, are going to get completely remodeled, renovated, washed away by the next high tide and the next storm event, right? No big deal. Leave no trace, yay. But for those dunes that we crossed, that one family's pass, one time, is enough to cut those root hairs and make, it's called an incision, perpendicular to the way that the dunes are running. And then the dune erodes sideways until there's no more dune. And that's going to be a problem for your wildlife. Lots of creatures need to nest in those dunes. A single family of humans can wreck a set of dunes. So we'll see raised boardwalks out to beaches to physically separate feet from that soil. It's just not resistant to damage. If it's a very clay pan soil, we're going to have trouble for a long time with shrink swell. How many of you guys and gals have taken any soils classes? Cool, about half the class, good. And a good distribution among the group. So for those of you who have, kind of help out your teammates who haven't maybe taken a soils class yet. We want to get a sense of, just at a broad scale, maybe top half dozen, what's the general soil textures we're looking at? Is this 100% like loose sand, poorly consolidated, low adherence, the particles don't stick together, but it drains really well? Is it the opposite, where it's all clay particles, all the real tiny stuff, and the electrostatic attraction glues those particles together really well, and that's a problem, like almost too well? Do we have a nice kind of 30-30-30 and 10% organic material blend of all three soil particle sizes, maybe some coarse fragments in there, so anything larger than a couple of millimeters? That's going to be pretty resistant to our impacts. We can walk people over a sand, silt, clay mixture trail with coarse particles all day and all night, and it's going to be there tomorrow just fine. Okay? So, in some of these places where we have homogeneous soil types where it's pure sand or it's pure clay, we're going to have to treat that with kid gloves. We're going to have to build some boardwalks. We're going to need to pave some roads around some clay pan areas to kind of separate us from the impacts we cause on those vulnerable soil types. If we have a more mixed heterogeneous soil type, it's a better balance of particle sizes and some organic material, then we don't have to worry about it so much. And we'll see that reflected in your park's placement of trails, in its placement of parking lots and roads. And another way that you can get a real good clue on this is what kind of restrictions are present for activities. So soil type is a major determinant of stuff like, can I ride horses here and still have the trail in decent shape tomorrow if it rained earlier today? Anybody been to Jubilee State Park here in Illinois, a little bit further north? Okay, so over by Peoria? Yeah. Worked on a research project with them, a bunch of horseback riders there. The park superintendent had taken to shutting down the park's riding trail system every time it rained. And people were rightly pissed off about it. So we got to go up there with a whole research group and just kind of camp for a couple days, meet everybody, and just kind of talk it out. And the question was, okay, so are we being fed a line of BS here? Are we getting shut out of our parks? You know, like our tax dollars support this place, create it, keep it open. And every time it rains, we can't do a thing here. And turns out the superintendent was right. Like the particular soil texture they had there, called Peoria Loess, has a bunch of real fine, poorly consolidated so it doesn't stick together. Basically talcum powder, baby powder, texture soil. Real small particles, windblown over from Missouri after the last ice age, or between the last few. And man, I mean, somebody farts in Massachusetts and blows away 6 feet of that soil here in Illinois. Like, it is super, super erosive. And as a park manager, that person had to make a difficult call to shut it down for a day or two after every time it rained at Jubilee State Park. So take a look at the mix of your activities on site. Can people go ATVing on your soils? Probably not, unless it's a bunch of coarse fragments like at Land Between the Lakes over in Kentucky, or if it's solid bedrock. Anything less than that just can't stand up to the torque that we have with modern internal combustion engines, and torque is even higher with electric vehicles at 0 RPMs. So take a look at the list of activities to get some context clues about your soils. So if you hear the word like sedimentation and stratigraphy, that's a phrase, not a word, and you start falling asleep, hey, me too. But take a look at the recreation activities, the forest rec, things that you can do on site, and that'll give you some real good clues about what the soil quality is like. Here at Mammoth Cave, our example, you can mountain bike, you can horseback ride, you can walk, and that's largely because this super dissolvable limestone stuff, as it's getting eaten alive or eaten geologically by the Green River and by slightly acidified rain, it leaves behind a bajillion of coarse fragments. And a horse is not going to harm a rock this big and flattened off by stepping on it. We can do that all day long, okay? So that's a clue here at Mammoth Cave. What kinds of trails do you have? What kinds of activities are allowed on those trails? If it's a multi-use trail, like hiking and horseback riding, and maybe on alternate days mountain biking, that's probably a pretty well-balanced, pretty robust, or resistant to impact is our keyword. Soils are not particularly resilient from impacts, not able to spring back and resume functioning. But they can be resistant. Bedrock, extremely resistant. Lots of coarse fragments present, extremely resistant. Sand, Loose sand, at the opposite end of the spectrum, not at all resistant. Like, you can blow on sand and displace particles. But we tend to find sand in places that are deeply channelized or relatively very flat. And every time there's a storm or a flash flood event or whatever, a bunch of that sand is getting sort of remodeled into the next generation of that sandbar, or blasted downstream and eventually out into the Atlantic or the Pacific, where it incorporates into the ocean floor, and it's not our problem anymore. So, if you want to go rafting down the Colorado River in the Grand Canyon, if your parents didn't put in for your permit before you were born, you're probably not going to get to do it before you die, because it's very high demand. But B, we don't care so much if people are walking on the tiny little sandbars in the Grand Canyon along the Colorado River, because, well, before we dammed it, the annual spring floods would just crap everything out downstream. They join the Rio Grande and boom, everything's gone. And so it was fine. Like if there was human feces or whatever, little bits of litter even, unfortunately, it all just gets blasted downstream. But you put a dam in above and below the Grand Canyon National Park, and all of a sudden it's a very low, very regulated flow, and nothing gets flushed out. So they had to adapt how they do the management there, not because of water, well, because of water as well, but mainly for the soil. So once or twice a year, typically, they open up the floodgates and they blast everything downstream, simulating the typical annual flooding of the Colorado River prior to us damming everything so we could have Las Vegas. Does that make sense? Okay, cool. So look at the activities. If you're not real sure how to sort of look up detailed information about the soils of your park, that's okay. We can get a lot of information on what the Park Service has figured out, what we can sustain on site in terms of activities. Cool. Clear as mud, no pun intended. You also want to take a look at what's the extent, what's the coverage of soils on site. At Zion National Park, like not very much of it is functional soil. It's a ton of exposed bedrock though. And yeah, you can run activities over exposed, well-consolidated sandstone like Navajo sandstone forever, except for rock climbing. The ropes chainsaw right into the material. It ruins the rope, kills the climber, and leaves a permanent mark. Whole other story with that. We'll get to that later. But is it lots and lots of thick prairie mollisols? Is it covered in 150 feet straight from top to bottom of good, viable soils like in parts of Kansas? And we have the Oregon Trail cutting a 150-foot deep slit trench through that, where it's eroded down to that over time. That's a pretty good clue that probably can't do horse or, Conestoga wagon-based recreation, if that's your jam, in that kind of soil. Over bedrock, yeah, that's fine. Okay. So what's the extent and what's the basic character of the soil? And we're going to simplify that down to what's the soil's texture, or the fraction of sand, silt, clay, organic material, and coarse particles. Coarse particles are everything larger than a sand grain, which is 2 millimeters on up to house-sized boulders. Okay. Cool. So, for your park, you tell me. Just based on what you know so far. I already gave you a clue with Zion. What is Isle Royal like? Is it covered in soil? Is it bare rock? Denuded? Lifeless? What do you think? What was your 40,000-foot picture of Isle Royal?
Lots of vegetation.
Okay, so there's a bunch of soil there. Got it. How about for St. John or Virgin Islands National Park?
Vegetation.
Okay.
A lot of they have a volcano there, so there's also some volcanic ash, I'm guessing. And
Like
sand
open ash
around
fields?
it.
Cool. All right. Sweet. Volcanoes you have to treat individually because sometimes you'll get like this pumice cinder spray that's super nutrient rich, or it could be like chock full of sulfuric acid and just wash all those nutrients out with all that acid. You just never quite know what you're going to get. Yeah. All right. For Lewis and Clark and for C&O Canal National Historic Park, what kinds of soils are you guys going to be crossing? Oh my gosh, that's a huge, huge question. But is it mostly over bedrock or mostly through vegetated areas for either one of those? What do you think?
There's like a lot of buildings by the so there's not much nature sand.
You guys are C&O Canal? Yeah. All right, so again, some of the richest, most expensive neighborhoods on the planet are in Marin County, Dubai, and in the village of Potomac, which is right, it literally touches C&O Canal National Historic Park towards the downstream side in D.C. And those people don't like to live in blasted, open, treeless landscapes. So there's some real soil going on there. Cool. And you guys will learn about some trench mining for gold right there as well. You can still sort of break your ankle on those. It's pretty cool. So yeah, there's soil to dig into. Look for gold. Cool. All right. So the main things we need to be kind of working towards in terms of getting to know your park's soils are the characteristics of soil strength as a function of that texture. So any kind of pure sand, silt, or clay, not going to be particularly resistant or resilient. It's going to have low soil strength. Okay. And once we have some drier days, we'll practice soil penetrometry and just experimentally like needling into soil to simulate things like a horse's hoof to see, can we chip it away? Like, does each horse create a non-zero number of kilograms of displaced soil we call dirt and throw it to the side of the trail? If you carve a line pretty aggressively with your mountain bike, mountain bikes do not displace soil when you're just rolling along, even with those aggressively knobby tires. In the same way that, in the opposite way that like a four-wheeler or quad side-by-side, because there's active torque applied to at least some of the wheels, maybe all four or all six, those knobbies will tear up the soil and throw up those big rooster tails that are so sexy in the marketing campaigns. Like you get the real dark, contrasty photos of like somebody driving a gator like up Mount Everest, and it's got this big brown rooster shit that's like, I feel like God, you know. Well, that's a lot of soil erosion, really, and we're marketing that. So you don't want to be the forester or the park ranger in charge of a place where folks are arriving with the conception of, we just trailered our awesome, souped-up $80,000 side-by-side over here, and we're about to get turned up on Zerp and drive like maniacs. If your soil can't handle that, if you're pure bedrock, like some of these parks are, you don't care, that's fine, whatever, go at it. You know, we have entire businesses perched around those particular parks filled with Humvees and souped up, like super wide, squatty stands, you know, jacked up Jeeps that can go up a cliff. And it's fun. They do it all year round. It's tons of fun because the bedrock doesn't care. It's kind of like that country song. The highway don't care. But we do. We do. Because we're foresters. So, in places with sandy soil or Peoria Lust soil, we can't get away with any of that. We're going to have to shut down our trail networks against hikers and horseback riders for a couple of days at a time to let those soils dry out. Now, we can't amend that. We can bring some of those materials out and, like if it's a pure sandy soil, bring in some silt, bring in some clay, and kind of stabilize some of those soils and make them much stronger. But that's hard work. That's schlepping dirt and rocks, sometimes in a backpack, one load at a time, as we do in some wilderness areas, to get any of the soil stabilized whatsoever. That's a ton of sweat equity. So we'll see. All right? Cool. Let's end a couple of minutes early today, and I'll be around for questions. Your assignment, your goal for Monday is to come on back with your group having some kind of a working understanding of what kind of soil resources you're looking at. Based on the topography, it's going to collect soil in places, it's going to wash it away in others, and based on apparent bedrock material that soil is being generated out of. All right? We'll see you Monday.